Hi Algebra 1 people, I hope you all had a wonderful spring break. So here is our first lesson. It's going to be average rate of change from linear, quadratic, and exponential equations. So basically we're trying to figure out this new term y'all haven't learned yet, which is the average rate of change. So y'all never seen this word, however we have done basically the concept of average rate of change. Average rate of change is just basically finding the slope of 2 points. So, if y'all remember your slope formula, m is equal to y2 minus y1 all over x sub 2 minus x sub 1. Okay, so we're basically using the same idea. How they write it for average rate of change, they're usually abbreviated as ARC, okay, is let's say we have A and B as my two x values, so x is equal to A, and then also x is equal to B. My average rate of change would just be like B minus A, and then f of B minus f of A. And if you remember this from function notation, this is just basically saying the y value at the given x value. So that's your average rate of change. Now, how this, most of the time we've only used slope for linear functions, but basically we're going to look at just like a snapshot of the graph and the slope at like the snapshot of that. So here's a snapshot we're given for this first question. And it'll make more sense when we get to graphs as well. But I'm just going to kind of show you the formula like in math. There's a process. It's the same process for every single time we do these. So find the average rate of change, from x is equal to -1 to x is equal to -2 for each of the functions below. So let's start with this first one. And I'll show you how there's a little shortcut for linear functions that we can really just look at the slope. Okay, and that's just for linear functions, but let's go ahead and follow the process. So we know, let's just look at x is equal to -1. Okay, when x is equal to -1, I'm going to plug this -1 into my function. So we're trying to find a of -1, which would equal 2 times -1 plus 3. And so 2 times -1 is -2. -2 plus 3 is equal to 1. Okay, so we know our coordinate point, or our y value, but our coordinate point represented here would be -1, 1. Okay, so that's step number 1. Then we're going to do that for the second x value that we're given. So instead of x is equal to -1, we'll say x is equal to -2. And this time we're going to find a sub 2, or not a sub 2, a of 2. And then we'll do 2 times 2 plus 3. And again, 2 times 2 is 4 plus 3, that's 7. So the coordinate point represented here would be 2. And my y value at 2 for this function is 7. Okay? So we're given 2 points. And something we've done in the past is we have found the slope for 2 points. So that's all we're doing. After we have these 2 points, we're then going to find our slope. So we're going to label these x sub 1, y sub 1, x sub 2, y sub 2. And then we're just going to plug it into that slope formula I was talking about at the very beginning. Whoops, sorry, this is y. Okay, so when we plug these in, we get 7 minus 1 all over, you can see that, 2 minus -1. Okay, and if we have a negative and a negative, this becomes a positive. Okay, so my slope between these 2 points is 7 minus 1, which is 6, and then 2 plus 1, which is 3. And so you'll see that our average rate of change from -1 to 2 is 2. Okay, so this seems like a lot of work, but you'll be able to do this a little quicker as we do more problems. Okay, so that's how we found it for a linear function. So again, notice that our answer was 2 and our slope is 2. So there's 4 linear functions, right? And we were able to recognize linear functions in our last lesson, or last time we were together. But this is a linear function because my x is not in my exponents and it's not squared. Okay, so for linear functions, you can just look at the slope and that can be your average rate of change. Now, For quadratics, it's not like that. Okay, I'm gonna kind of section this off. I need to make sure I don't go into the other spaces. Okay, I'll try it smaller this time. All right, so we're gonna do the same thing where x is equal to -1. I'll plug it in. So b of -1 would be -1 squared minus 1. -1 squared is +1. 1 minus 1 is 0. Okay, and so my point here would be -1, 0. Okay, so same thing we just did over here, but for a different function. All right, then over here we're going to do x is equal to 2. So we'll do b of 2 is equal to, we're plugging it in for x. 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. So coordinate point I'm given is 2, 3. Okay, and then again we're going to use our slope formula. Okay, and we're just going to plug these in after I label them. X sub 1, y sub 1, x sub 2, y sub 2. Okay, and we're just plugging them in. So 3 minus 0 all over 2 minus -1. So this is 3 over 3 because we are adding here. So this is equal to 1. So our average rate of change is 1 for that quadratic. Okay, and I don't want you to associate this 1 with anything in this equation. So it'll be different. Here, regardless of whatever x values you're looking at, it's always going to be 2. For this one, it'll be multiple different answers. So you can't use that same idea that you use for a linear function with a quadratic function. And we know this is quadratic because of this x squared. Okay? All right, last one is an exponential function. We'll do the same thing. X is equal to -1. Okay? So we're going to plug this in. So c of -1 would be c to the -1 power plus 1. So I don't know if you guys remember these exponent rules, but basically this means, okay, that all this is going in the denominator. So 2 to the first power would be in our denominator. Okay, so that was with our exponent rules that we had in a previous chapter. Okay, so basically this is 2 to the first power is just 2. So this is 1/2 plus 1. So we know 1/2 is the same thing as 0.5. So this is 1.5. Okay, so our coordinate point for this one is -1, 1.5. And then we'll look at x is equal to 2. And then we're going to plug this one in. C of 2 is equal to 2 to the second power plus 1. Okay, so 2 to the second power is just 4. 4 plus 1 is 5. Okay, so that one was a little easier than the last one. So 2, 5 is my other point. Okay, so we're going to label them again. X sub 1, y sub 1. And you notice how you get quicker with these because it's just like the same pattern every time. You plug in the x value, find the y value, find the points, and then plug it into your equation. So again, your equation is, if you don't know this already, you should, because we've used this enough. But basically you are going to plug these in. So 5 minus 1.5 all over 2 minus -1. So this is 3.5, and this is plus. And so at this point, I would get my calculator out. And my calculator would give me, oh no, I didn't get my calculator. Oh, it's in here. You probably already have your calculator on you. You're doing better than Miss Garner is. Okay. So basically this is what we do. We just put 3.5 divided by 5 in our calculator. Okay. It should be around 1, right? Because 3 over 3 is 1. But I just want to make sure. Yeah. So it's like around 1.166, so 1.17. Okay, so we're going to look at all these. So we have 1.17, we have 1 and we have 2. And so it's asking me which function has the greatest average rate of change from the interval 1 to 2. So you notice it said from negative 1 to 2. And gave us these two x values. So this is what it means. The interval is the x values. And so we're just basically taking the snapshot on the graph from x is equal to -1 to 2, which one is going up the fastest, okay? And so right at this moment, right, which is the greatest number, 1.17, 1, or 2, okay? The 2 is the greatest one. So I would just say, which function, that would be a of x equals 2x plus 3. This is the winner, okay? Because, mess up. Because 2 is greater than 1 and 1.17, okay? All right, so go ahead and pause the video and see if you can do these 3 on your own, and then I'm going to go over them. Okay, welcome back. All right, so I'm just going to run through these real quick because you should have already done them. So here we go. So my first x value is x is equal to 2. My second one is x is equal to 5, and I'll kind of section it off. I'm going to go ahead and section off my my area just so I don't work into the other places like I did last time. Okay, so I'm going to plug this in. 2 times 2 plus 1 is equal to 5. So 2 comma 5 is my first point. 2 times 5 plus 1, this is equal to 10. 10 plus 1 is 11. So this is 5 comma 11. And then I'm going to plug it into my slope formula. So this will be 11 minus 5 all over 5 minus 2. And I kind of skipped some steps. So if you need to go back to the last problem and see what I'm doing here, you can. 11 minus 5 is 6 all over 3. So this is 2. And I did go into the other separation. Here we go. There we go. So 2. And notice with linear functions again, okay, you could have looked right here and seen, okay, it's going to be 2. All right, but I'll go ahead and I'll actually label these. Oops. Okay, y2 minus y1 is 6. 5 minus 2 is 3. Okay, so, and 6 divided by 3 is 2. When you're doing these problems, make sure you have a scratch paper next to you and you're really working through them, because it's easy to like flip the x and the y, or to just subtract wrong or plug things in wrong, not follow order operations. So just make sure you're working through these step by step. Okay, enough talking. Here we go. So check your answers again. So this is 2 squared plus 2. 4 plus 2 is 6. So 2 comma 6 is my first point. And then we have x equal to 5. 5 squared plus 2 is equal to 25 plus 2, which is 27. Oh, that's a big number. So we have 5 comma 27. All right, and so then we'll have 27 minus 6. So, because again, this is x sub 1, y sub 1. This is x sub 2, y sub 2. Okay, and so I'm just doing y sub 2 minus y sub 1, 27 minus 6, and then I'm doing 5 minus 2. Okay, so this is 27 minus 6, which is 21. Oops. All over 3, so this gives me 7. So my average rate of change from 2 to 5 for this quadratic is 7. Okay, so it's not following the same pattern as the one above. Notice this quadratic is the biggest right now, so let's see who's the biggest. Average rate of change. Okay, all right, so then I'm going to do this last one. Okay, plugging it in. 2 squared is 4. 4 minus 1 is 3. So this is 2 comma 3. And then we'll do 2 to the 5th minus 1. Where's my, okay. Oh, sorry. 2 to the 5th, which is 2 times 2 times 2 times 2 times 2, which is 32. 32 minus 1 is 31. Okay. And you can put 2 to the 5th in your calculator, not do what I did, 2 times 2 times 2 times 2. It'll probably save you time. But then, so my point is 5, 31. Okay, so when I set this up, x sub 1, y sub 1, x sub 2, y sub 2. And then we'll subtract these 31 minus 3 divided by 5 minus 2. So this is 28 all over 3. Okay, this is about 9.3. Okay, so my average rate of change for this exponential function from 2 to 5 is 9.3. For the quadratic is 7, and then for the linear function it's 2. So when it goes down to this last problem, most of the time you will have this last problem that you'll ask, okay, which function has the greatest average rate of change over the interval 2, 5? So we'll look at all these, 2, 7, and 9. Which one's the biggest? Oh, 9. 9.3. So c of x is equal to 2 to the x minus 1 is my winner. Okay? So you'd say the exponential function here, the linear function was actually the biggest there. Okay? So, again, we're just looking at these at a snapshot, but let's talk about, okay, what if we were looking at a graph from, like, if it was going on forever, and that's what this little fancy symbol means. Okay, this sideways 8. Okay? In general, as x goes to infinity, so as x is going on and on and on forever and ever and ever, which function eventually grows at the fastest rate? Okay, so I'm going to just kind of show you all the graphs. So here's a graph, estimated graph of a linear function, a quadratic, and an exponential function. Okay, so with a linear function, okay, it's just going to have a constant rate, just kind of going up and up forever and ever and ever, okay? Now, as a quadratic goes up, it's just going to kind of go up, and it's going to go up faster than the linear function, but it's not going to go shooting up like super fast. So notice that this exponential function, it starts really, really low and then suddenly goes up. Okay, so the winner of this one that was going to grow at the fastest rate, okay, notice it started really, really low and goes really up super high. Okay, and I mean, this quadratic did too, but it's not always this steep, okay? But the winner is basically, this is what you need to memorize, okay? Exponential functions. As x is going to infinity, grows the fastest. And this could be a quiz question, so you might want to star this to make sure you understand that, okay? As we're going to infinity, as we're going forever and ever, not looking just at a snapshot, okay? Exponential functions always win. All right, so that's it. That's the first lesson, and we're going to look at tables and graphs next time. So I'll see y'all then. Bye.